Okay, this standard is about rational inequalities, and it's only asking us to determine the solutions to them using graphs and tables only. We are not having to solve these algebraically at all, just using graphs and tables. So I'm going to be using a calculator for solving these questions. So the first question is this equation 5 over x minus 2, and they want to know when is it less than 0. So I'm going to start by graphing it. So in my graph, control divide from my fraction template, I'm graphing 5 over x minus 2 on the left side. And I'm also going to graph the right side, which is 0. So I'm going to graph both sides. I also like to see the grid. So I'm going to go menu, view, grid, line grid. And you don't have to do that, but I really like to see that on my graph. I'm going to snapshot this so that we can go and write on it easily. So, and paste. Okay, so there's my graph for that equation. And before we talk more about the answer, I want us to identify our asymptotes because they are going to be an important part of our answer here. So, this equation has a vertical asymptote of x equals 2. Remember that you set the denominator equal to 0 and solve, you would get x equals 2. It has a horizontal asymptote. So if you look at, and just look at the left side of this to determine that, has a higher power of x on the bottom. So that means that the number for this horizontal asymptote would normally be like plus or minus added on the end out here, and there isn't one. So that means that the horizontal asymptote is y equals 0. So this graph is never going to touch y equals 0. So it's never going to reach there. And the vertical asymptote is at 2. It's also never going to touch this line here. It's important for us to answer this question to know those things. So in my graph, the part of the graph where it's less than 0, so the part of the graph that we want to answer this question, it's saying when is it less than 0? So in the graph, the area where it's less than 0 is this part of the graph. And it's going to keep going, and it's going to get really close to 0, but it's never going to touch it. Or sorry, really close to 2, but it's never going to touch it. And it's going to get really close to 0, but it's never going to touch it. So the answer to this question is all of this part of the graph is where it's less than 0. So to write that answer, if it keeps going left, eventually it will approach negative infinity. And as you go to the right side of this, it's going to get infinitely close to 2, but it's not going to touch 2. So the answer to this question is negative infinity up to 2, and it's not including either of those because it doesn't have the little equals bar, and it's never going to touch the 2 because that's the asymptote anyways. So this is the answer to this question. And you can look at that also on a table, since the other method for solving this is a table. In my calculator, if I go back to the graph that I was on and I hit Control T to get my table, you can see that at 2 it's undefined, and they want to know when is it less than 0. So looking at your y values, over here it's higher than 0, back here it's less than 0, at 2 it's undefined. So, and then as you go backward, you can see it's going to get close to 0, but it's never going to get to 0, and it's going to keep staying below 0. So, you know, that would go on forever. So that's how you know that it gets up to 2, but it doesn't include 2 because it's undefined, and you want to go backwards in the table. So you want to go back to negative infinity because it's never actually going to reach 0 that direction.